Alright, Assalamualaikum, selamat petang.
Salam sir.
Boleh nampak nota ni?
Nampak sir.
Okay, thank you. Alright, as we have promised yesterday, we are going to continue with the last part of kinematic, which is regarding projectile. Okay, sekejap. Tengok apa ada dulu. Sikit je. Okay. So, before we go to the notes ni nanti kamu baca lah sendiri. Projectile. Okay, in order to make a thing to be a projectile, we need to have a properties. Okay, satu benda. And this properties is known as a free body diagram. Okay, when we have this, and then we know it is a projectile case. Okay, apa itu free body diagram? First, you need an object, a properties. And this object need to subjected to only three variables. Okay, they subjected to these three variable only. One, external force, which cause the object to move. Two, drag ataupun friction, which works in vice versa direction from the force. And number three, gravity. So any object which has this variable is known as free body diagram. Example, bola, kita sepak dia. So when we kick the ball, we give the ball force. The ball going to move in the direction of the force being applied. Bila dia bergerak, they will subjected to drag ataupun friction. At the same time, there will be gravity pulling it downward. So ball is a projectile. Okay. Manusia terbang, lompat tinggi, doing somersault whatsoever. So during this action, this manusia is subjected to force being applied to action reaction. At the same time, they are drag and of course gravity. So at this moment, human is a projectile. Okay, kapal terbang. This kapal terbang has engine, which is known as thruster ataupun thrust lah. Okay, thruster, which give the kapal terbang enough push, and this thruster enable the flight or enable the aeroplane to change direction mid-flight. This is not a projectile because it is not being subjected to external force. Jadi apa-apa benda yang melayang, senang cerita, is a projectile. Okay, any action in this world, most of it is actually a projectile. Okay, action macam mana? Katalah bola sepak tadi. We kick the ball. It cause the ball to travel. So for a projectile, it will involve two components. One component is known as horizontal component. Another one is vertical component. Okay. In most usual form of projectile, you are going to see something like this. Pergerakan dia baik macam ni. This pergerakan is known as trajectory. So, to describe trajectory, we can describe it in term of these two. Yang memanjang ini namanya horizontal component. Yang menegak ini namanya vertical component. Okay, so if we take a look at this trajectory, we can say that the horizontal component is much larger compared to the vertical component. Jadi kadang-kadang kita jumpa trajectory yang macam ni. Weh, naik ke atas. Where the vertical component is larger than horizontal component. Either way, this is a projection ataupun projectile. Okay. Bola sepak. Sepak kita nampak dia tegak je. But if you go very detail with high speed camera, you can see the ball have curve. Projectile. Okay. Ataupun we kick a ball from a height. Bawah. This is also a projectile. Which this one serve as the vertical component. This one serve as the horizontal component. Ini adalah projectile. Okay, sampai sini. Boleh faham apa itu projectile? Or this one, a free body diagram. So, any free body diagram move through the fluid condition, move through the air, is a projectile. Okay, lagi satu nak faham projectile ni, they cannot change their projection, ni trajectory ni ataupun dia punya projection. Projectile cannot change their projection mid-air. So, kalau dia boleh change dia punya projection mid-air, that is not a projectile. Okay. Kita ambil contoh skydiving. Okay, kapal terbang and then people jump from the airplane. This is airplane, jump down. Okay, bila dia jump down, dia akan melayang and then dia change direction, dia melayang sampailah dia landing. Is it a projectile? For this case, okay, apa ni? Skydiver. Is it a projectile? Hello. Buang kelas. Projectile ke bukan projectile? Skydiving. Think carefully.
Projectile kot, sir.
Kenapa?
Sebab dia ada dua-dua komponen.
Dia ada dua-dua komponen. Can this skydivers change its flight pathway? Boleh tak dia ubah dia punya?
Tak boleh.
Tak boleh. Boleh ke tak boleh? Macam kapal terbang. Can they do that? Or cannot? Jawapan kamu dah hampir-hampir tepat tu. Dah hampir-hampir tepat tu. Okay. So if we take a look here. Orang ni. Dia ada gravity. Dia ada drag. Dia ada force. This is some sort of projectile. However, projectile punya projection macam ni. Ataupun macam ni. Ataupun macam ni. Macam ni. Okay. Can this person being called a projectile because it able to swerve ataupun it able to curve. It is not a straight one. Is it a projectile? This is a free body diagram. Ini adalah projectile. Okay, so projection dia mana? Inilah projection dia daripada atas ke bawah. So this will serve as the vertical component as your friend say, and this will serve as the horizontal component. Yang tak boleh kita panggil projectile orang ni kan, manusia ni, kalau dia pakai jetpack. Oh, sorry. Tadi dia dah jatuh, lepas tu bila naik balik, change direction, wah, naik atas. This is not projectile. Okay. As long as dia melayang, jatuh ke bawah, do the pathway, mengapu-apu, this is a projectile because it consists of free body diagram and it has trajectory. Means it has a pathway which consists of both vertical and horizontal component. So skydiving is an example of a projectile. Okay. Tu projectile asas dia. Okay. So apa yang akan ada dekat projectile? We are going to have pathway ataupun trajectory. Okay. And this trajectory consists of two components like I said earlier, which is the horizontal component and vertical component. Itu dia perkara yang asas. Okay, this is known as trajectory. Melengkung ni. Trajectory is the lengkungan, ataupun if we want to describe a projectile, we can describe in term of ini ni, in term of theorem Pythagoras. Okay, yang mana kita ada, we have angle, opposite side, adjacent side, and hypotenuse. So trajectory is ada hypotenuse. Okay, so trajectory of a projection, we can divide this into 3 part. Satu is the up part. Number 2 is the apex. And number 3 is the down part. So analysis of projectile, kita boleh analyze benda-benda ni. We can analyze the horizontal, we may analyze the vertical, we may analyze what happened at the apex, and we also analyze what happened at the up and down part. Projectile. Okay, and there are 3 factors determining the range of the projectile. The first one is the angle. Angle of projection. This is the first factor affecting range. Ni kita ada 2 range. This is also known as range horizontal and range vertical. Number 2 is the speed of projection. And number 3 is the relative height of the projection. Okay, number 1 dengan number 2 is quite clear. This is number 1. Number 2 is this one. How fast the object goes upward. Dia punya velocity. But in projectile, since we have hypotenuse, since we have the curve, this curve can only being present with the presence of a combination between adjacent dengan opposite. Jadi dalam kes projectile, dia bukan V semata-mata, but the V here is V sin theta. Ni kita kena include the angle. Okay, we need to include the angle because a projectile is a projection. It is not a straight line. It is a projection. Maksudnya dia adalah resultant. It is not scalar. Dia vektor. Dia resultant. So, V here is V sin theta. Ni selalu kita panggil sebagai V initial lah. And then at the apex, V always equals to 0. Okay, ni maklumat asas yang kamu kena tahu. And then, we have acceleration. If the case is a vertical case, acceleration equals to negative G. Ataupun negative 9.81 lah. But, if the case is horizontal, A equals to 0. Because, at any point of this horizontal plane, the gravitational force is equal. Tak pernah berubah. Okay. Tu maklumat-maklumat asas dia. Alright. We go to the third one. Relative height. Okay. Relative height is difference of height between start and end. Okay. Jadi relative height ni kita ada 3. Okay. Kita ada relative height 0, relative height 1, relative height negative 1. Okay. So apa beza dia? If relative height 0, it means that your start and your end point is at the same level, which make the best angle to get the longest range is equals to 45 degree. Okay. Kalau relative height plus 1 means that your start is higher. Contoh kita main golf ke apa kan, kita tee off tinggi, kita punya hole dekat bawah. Ni relative height equals to 1. Ni relative height equals to 0. Okay, in here, the best angle to get the best range is not 45 anymore, but it is less than 45. Kalau kita bagi dia 45, dia pergi macam ni lah. 45. Kita nak dia pergi sini. Okay, and the third one is when your start is lower than your end. Jadi angle kita macam ni. Okay, this is relative height. Besar aku letak RE, sorry. RH, relative height equals to negative 1. Where the best angle is more than 45 degree. Ni angle projection ni kena lebih pada 45. Kalau kita bagi dia 45, ya dia bagi ni tak dapatlah masuk dalam hole. Ni contoh macam basketball, netball. Relative height should only able to predict this one. Ni maksud dia je lah. So relative height, most of our case is actually relative height equals to 0. So 45 degree is the best one. Nanti kita tengok kenapa 45 degree. Okay, sampai sini dulu. We have projectile. We have factor affecting projectile. Boleh dapat?
Boleh sir.
Boleh. Okay. Next one is about equation of constant acceleration. Okay, so we have three. You have three equations to be remembered. This is the first one. V2 equals to V1 plus AT. Number 2 is D equals to V1T plus half AT square. And number 3 is V2 square equals to V1 square plus 2AD. Ni tiga equation ni. Kalau tengok nota ni kat ujung sekali ada. Tu dia. Okay. This is the equation. Ni tak nampak ni. Yang atas ni V1 plus AT. Okay. So, what this three equation talks about? It talks about this. Where it talks about projection. Where the first equation, most of the time being used to find out time. Either time for the up version or time for the down version, the down portion. Itu yang pertama. As for the second equation, this one is more likely to serve the horizontal range. D is range. Okay, this D is range. While for the third one is for vertical. Vertical case. This one is for horizontal case. Ini adalah equation yang kita selalu guna untuk solve problem dekat projectile. Okay. And then, okay, based on this equation, we able to prove some basic information. Okay, for example, in a projectile, the time taken of an object to reach apex, okay, 1, 2, 3. 1 kepada 2 is always equals with 2 kepada 3. Masa yang diambil. In other words, it serve the same the same properties. It gives you the same values. Okay. So now I'm going to show you how to prove things happen in here. Okay. First, we are going to prove the time taken is equal, and number 2, we are going to prove 45 degree tadi ni. Kenapa benda ni akan dapatkan kamu range maximum. Okay, we'll go to the first one. Okay, the first one, we are going to start with the first equation equals to V1 plus AT, where it talks about the first part. It talks about T up. Bahagian naik ni dulu. Okay, so when we talk about the first part, we know that ini kita ada dua velocity. V1 will be at the bottom V2 will be at the apex. Automatically, V2 ni information yang kamu kena ada, okay, equals to 0. Because at the apex, we don't have any velocity. And V1 equals to V sin theta. Okay, why sin? In order to answer that, kita kena faham sin, cos, tangent. Sin equals to opposite hypotenuse, cos equals to adjacent hypotenuse, tan equals to opposite adjacent. If your angle is here, the plane that is opposite of that is known as the opposite plane, and the plane that attached to the same angle is known as adjacent. Dia punya yang paling panjang is your hypotenuse, and always remember this. It doesn't matter if your case is horizontal or your case is vertical. When your case is projectile, we need to include hypotenuse. Jadi, kalau case horizontal, your value need to be the adjacent value and hypotenuse, cos. Cara untuk kita pilih. And if your case is vertical, your value need to be opposite and hypotenuse. Sin. Cos apa? Cos theta lah. Jadi velocity dia tak boleh velocity semata. It need to include component yang diperlukan. So in this case, V1 at the bottom, V2 at the top. So it is an inclination case. Means it involve hypotenuse dengan how high. That is the reason why we choose sin. Okay. And then next information is about A. Kita ada A ni, which is negative G. Ini maklumat asas. Okay. Whenever you try to use the equation, this is some of the information that you may include with it. Okay. Now let's substitute this information into the equation. We are going to have 0 equals to V sin theta, and then we have plus negative G and T. Since we want to know T, okay, T up, so we are going to substitute, we are going to transfer this part to the left hand side, where we have GT equals to V sin theta. So T only is V sin theta over G, and this is T up. Okay. Jadi kalau kamu nak cari masa, kalau maklumat dia tak cukup, you can actually work to find time by using only velocity and angle. Dah boleh dapat. Kalau dah bagi time, tak payah nak buat kerja susah ni. This is how we want to prove. Okay. Now, later we are going to prove that T down is also the same thing. Okay, so to do so, we are going to consult the second equation, which is D equals to V1T plus half AT squared. And to consult this one, it works in the down part. Kita nak cari down kan? Down, T down, time down. Where at this one, V1 is at the top. Automatically, V1 is 0. Apa lagi yang kita tahu? T kita tak tahu lagi. A is negative G. Now we are going to substitute this one into the equation, where we have D equals to 0 T plus half A T squared. Okay. We send this one to the left first. So you have 2D. This one is going to be slashed out in 0. And then equals to negative GT squared. Okay. Kita dapat yang ini. Sorry. Dua ni hilang. D equals to negative half GT squared. Di sana. So 2D equals to GT squared. So T equals to 2D over Oh sorry, kita tak boleh mudahkan macam ni. Betul lah. So we have 2D equals to GT square. So apa yang kita nak pindahkan ke depan nanti? T. Okay. So T equals to 2D over G square root. Ada saya miss out ke? Sekejap V1 equals to 0, we slash that 1. T equals to half AT square negative G T square, and then we multiply in, we have negative half GT square equals to D. We substitute that one, we have 2D over GT square. And finally, T equals to 2D over G. Okay. Right. This is the first part for T down. Okay. First part. Okay. And then we are going to move to the second part involving the third equation. V2 square equals to V1 square plus 2AD. Yang ini menceritakan keseluruhan. So when it talks about everything, V1 will be here, V2 will be here. Automatically we know that V2 equals to 0, V1 equals to V sine theta, and A equals to negative G. Okay, so we substitute this information first. We have 0 square equals to V sine theta square plus 2 negative G D. Okay, so we try to omit this D. Okay, kita cuba untuk selesaikan D ni. Means this D part is going there. Okay, so kita ada 0 V sine theta square minus 2GD. Jadi kita pindahkan 2GD equals to V sine theta square, where D is V sine theta over 2G. Okay. Now we are going to substitute this D, the new D, into the first equation. Into the first part. Okay, where we have T equals to 2D over G square root. Kita masukkan di dalam ni. So kita akan dapat T equals to 2, D is V sine theta over 2G square over G square root. Square root ni kita boleh potong power of 2. 2 kita boleh potong 2. G dengan G ni, okay, dia macam G 1 1 G. So you are going to end up dengan G. Okay, jadi kita akan hilang 1. You are going to end up dengan 1 sahaja. Means you akan dapat apa yang tinggal ialah 2 semua dah habis. Kita tinggal V sin theta over G, which we have proved that T up equals to T down. Okay, sama dengan T up. Wait. Ni T up, V sin theta over G. So that is the first proof. Okay, next one, when we try to prove 45 degree is the best. Okay, so apa maklumat yang kita ada tadi? We have T up equals to T down. Okay, maksudnya the time taken up is equals to the time taken down. So T total will equals to T up plus T down. Ini maklumat baru. Okay, V sin theta over G plus V sin theta over G equals to 2V sin theta over G. Ada dua kan? Tu maklumat dia. Okay, next. Please recall what we have learned yesterday about distance and displacement. Okay. Macam mana kita nak cari distance? Macam mana kita nak cari displacement? Okay, kalau velocity equals to displacement over time. So, kalau kita terbalik kan, kita nak D. Macam mana kita nak buat? D equals to velocity kali dengan time. Okay, so here range ni, in order to find this range, the equation you need to have is equals to V kali T, where the V here is, ini adalah case horizontal. Ingat lagi tadi horizontal, kalau kita tengok case horizontal, the V is V cos theta. Okay, menjadikan that equation to be D equals to V cos theta kali T, and this T is T total. Kita teruskan lagi, it going to be V cos theta kali dengan 2 V sin theta over G. Kalilah masuk. So, kamu akan dapat apa ni? V square. Apa lagi? V dengan V, V square. Lepas tu, 2 sin theta cos theta. Okay. Sampai situ. Say okay? Ke dah jam lah? Are you still okay? Tolonglah kata okay. Weh, tak dengar. Okay, dengar macam suara robot dia. Are you okay? Kalau okay, kita akan teruskan.
Macam pening sikit.
Okay, pening kat mana? Tang mana?
Tak tahu nak cakap dekat mana tu.
Okay, I get this a lot actually. Pasal yang ini kita main pindah-pindah equation dia memang nampak aduh pening apa benda saya cakap ni seorang-seorang. Okay. Saya teruskan dulu. Kita dah kat sini.
Baik.
Kita dah kat sini. Macam mana kita sampai sini benda ni. Okay. Now we try to prove that ni 45 degree adalah angle terbaik untuk relative height 0. Okay, kita cuba provekan by getting 45, you are going to get the longest range. Okay, why? So for range, sekejap. Okay, for range, okay, jadi formula untuk range ni, if we go by the book, you are going to see formula macam ni tau. V cos theta t. So now I'm going to show why V cos theta t. Alright. Range is distance. Do you still remember what we learned yesterday? Okay. Distance equals to speed over time. Ingat ni? Ataupun velocity equals to distance bla balik. Sorry. Speed equals to distance over time. Ataupun semalam kita buat velocity equals to displacement over time. Ingat ni lagi? Do you still remember this one?
Yes, sir.
Yes. Okay, now our focus is the distance. Kalau kita nak cari distance, we need to rearrange this formula. Okay, kalau kata macam ni nampak macam payah nak faham kan? Okay, V equals to D bahagi T. Kalau kita nak D, D bahagi T equals to V. Jadi D saja equals to V, pindahkan, kali T. Nampak? Ni bentuk yang sama. This is the same shape. This is the V part, this is the T part. Okay, now why V cos theta? When we try to solve projection, we cannot neglect hypotenuse. Kita tak boleh lupakan ni di projection upwards. Jadi kita cuba dapatkan bahagian ini. But since this is a projectile, we need to include all these two. Ni kita panggil sebagai adjacent side. This we call it as opposite side. So for adjacent side, the best part of theorem Pythagoras that we are going to use is cos, because it involves adjacent and hypotenuse. And that is the reason why V dia ni jadi V cos theta. Okay, so kita dah dapat dah R or D. Some books put it as R, range. Some books put it as D, distance or displacement. It is equal. Kita dah dapat dah R equals to V cos theta kali dengan T. And this T is T total, which is T up plus T down, where we have proven that T up equals to V sin theta over G. T down pun V sin theta over G. Tambah dua-dua ni, kamu akan dapatlah 2 V sin theta over G. Sekarang kita dah dapat equation penuh. R equals to V cos theta times 2 V sin theta over G. Okay. So kalau kita nak darab benda macam ni, first, V dia akan darab dengan V. Benda yang sama boleh darab, benda tak sama kita turunkan je. So V darab dengan V, kita akan dapat V square. Cos theta, 2 darab dengan siapa? Tak ada. 2. Follow, yang lain just follow down. Sin theta, cos theta over G. Okay. When we reach here, okay, so based on the rules of trigonometrical identity, okay, ni benda yang kamu belajar masa sekolah dulu. Saya pun dah tak ingat dah bahasa Melayu dia apa. Okay, this part 2 sin theta cos theta is equal in term of value with sin 2 theta. Jadi kita boleh mudahkan equation ni. Kita akan dapat R equals to V square sin 2 theta over G. Okay, tekan muka surat sebelah. Alright. Now, since our focus is towards angle, in this equation, the part of the equation which talk about angle is this one. Okay, sin 2 theta. Ini sahaja yang ada kaitan dengan angle. So we are going to talk about this part. Now, in trigonometry, okay, in trigonometry, the maximum value of sin is 1. Okay, 1. So, what we try to have is, we try to have value of sin equals to 1. Sin berapa? Based on here lah. Sin berapa angle? Okay, jadi sin berapa sebenarnya? 1. It is sin 90. Okay, it is sin 90. So, if kita nak masuk sini sin theta ni, kalau 2 theta sama dengan 90, theta saja ialah 45 degree. And this prove that by having 45 degree, you are going to get the longest range because the multiplication is with the maximum number available. Jadi dia akan masuk macam ni lah, as sin 2 45 equals to 1. So this is how you prove 45 degree is the best angle if relative height of that projection is equals to 0 and start at the same level. Okay, dalam nota pun dia ada cerita benda yang sama. This one. Okay, kita tengok yang ini. This show maximum height and maximum range. The difference is just towards angle. Okay. If we take a look at this, we are going to notice that every two angle have one similar ridge. If you go too low, you end up here. If you go too high, you end up at the same place. But we have only one line ni kat ujung sekali ni, which get the longest ridge, and that line is 445 degree. Kalau kamu nak cuba kira ni, cuba lagi masukkan figure so sikit. You are going to notice that 45 degree is going to give you the longest R, simply because when we put 45 degree into the equation, this part of the equation will give you value of 1. Other than that, it will give you value less than 1, 0.8, 0.7, 0.6. So when we multiply with velocity and divide it with gravity, you're going to end up dengan value yang sedikit berbanding dengan 45 degree. Ini adalah projectile and equation of constant acceleration. So I'm going to give you some rules to work from. Okay, so for equation of constant acceleration, I'll repeat that. The first equation, v2 equals to v1 plus ini t, v1 plus at. This one serve mostly to settle up problem of time. Problem of time ataupun problem including v2 and v1. Maksudnya dia akan melibatkan time. Velocity involve time. And it is for the up portion. Okay. And v1 in here is v sin theta. Ingat. v2 here is 0. The second equation, d equals to v1t plus half at square, is for horizontal range. Okay, tengok betul-betul. Tengok baik-baik. And for this part, since it is horizontal range, it works in this condition where the v1 is at the top. So v1 equals to 0. Ini kalau kita nak cari T up, T down. Tapi kalau kita nak cari range, saya bagi dua-dua condition lah relation to equation number 1, v1 equals to 0 and a equals to negative g. Okay. If for if for horizontal case, horizontal range, okay, v1 equals to v cos theta, a equals to 0. Dia ada dua kegunaan. Tengok baik-baik equation ni. D equals to v1t plus half a t square. If this a being changed to 0, automatically yang ini kita boleh potong. Kamu tinggal v1t, where v1 equals to v cos theta. T lah. Nampak tak equation ni? This equation is actually the same equation as this one. V cos theta t. V cos theta t. This is second equation, which will serve as the horizontal part. Ni, D ni D for horizontal. Okay. And the third equation, v2 square plus v1 square, equal with v1 square plus 2ad. This one is for vertical height. Okay, where v1 is v sin theta, v2 is 0 kat apex, and a equals to negative g. Ni adalah tiga benda yang kamu kena ingat. Okay, because whenever you try to solve a problem for equation for projectile equation, these are the three equation that will be used most of the time. Okay, equation of constant acceleration, which talk about properties for projectile. Apa itu projectile? Free body diagram subjected to force, gravity, and drag, and it has projection, pathway, ataupun nama kampung dia trajectory, which include vertical component and horizontal component. This projection can be divided into three: relative height, where the start and ends at the same height, start higher than end, and start lower than end. This one is 0, this one is 1, this one is negative 1. Either way, all of these will have their own vertical component and also horizontal component. Ini adalah projectile. Okay, boleh? Are you okay? Are you KO? Which one? Okay kah? Okay kah? Oh, okay. Okay dok. Okay dok. Wih, sekejap okay tak okay ni?
Pening sir.
Pening.
Tak ada jawab saya.
Okay ke?
Betul sir.
Nanti review balik video ni. Jangan pening sangat. Okay, kita tengok satu contoh je lah. Simple example. Okay, simple example. Let's say we have an arrow. Kita ada satu arrow being released with a velocity of 45 meter per second, and this arrow being released at an angle of 10 degree. Contoh dia. So the question is, how far it can go? Di horizontal. Berapa jauh dia boleh pergi? Soalan ni. Okay, so apa yang kita perlukan? Kalau kita nak tengok di horizontal, equation dia ialah D equals to V1T plus half AT square. Okay, yang ini yang kita sudah tahu, and we know that in horizontal case acceleration dia kosong. Means A sini we can substitute with 0 and we can slash it out. Jadi D adalah V1T. Apa maklumat yang kita tak ada dekat sini? What are the information that we don't have here? T. T kita enggak ada. So macam mana kita nak cari T? Ingat balik equation tadi. Ini equation nombor 2. Equation mana yang kita guna untuk selesaikan masalah T? Equation 1. V2, ini V square. V2 equals to V1 plus AT. Boleh tak kita cari T dia sekarang? We know that V2 kosong. V1 ialah V sin theta plus negative G T. So V sin theta, can we have V sin theta? Yes. It is 45 kali dengan sin 10. Lepas tu apa? Kita ada minus dengan tak ada apa? Oh,
9.81.
9.81 T. Jadi kalau kita buat sini, kita ada 9.81 T equals to 45 sin 10. So T ialah 45 sin 10 9.81. Apa dapat?
0.8.
0.8 second. Okay. Now, kan saya nak kamu faham satu benda. Tolong ingat benda ni botol-botol, okay? T ni, yang kita dapat ni, daripada sini, okay? Ini adalah a portion of T. Ingat tadi ni kan equation nombor 1 ni untuk serve benda macam ni kan. So kita dapat T ni. Tapi T yang keseluruhan ni, ingat tak tadi kita punya formula R equals to V cos theta T. The T here is T total. So this 0.8 kita kena kalikan dengan 2 because this just T up. T down dia tak ada. So T total equals to 1.6 second. Barulah kita boleh selesaikan dekat equation R ataupun equation D ini. Where the first part V1 ialah 45 cos 10. Okay, because this is horizontal case, cos. Kali dengan 1.6. Apa kita dapat?
70.91.
70 point?
91.
Ya ke?
Salah ke?
Nanti kita tengok dulu. 0.98 kali dengan 45 kali dengan 1.6. 70.56 je. Kamu ambil cos tu semua sekali tadi Mana saya punya cos? Cos 10. Okay, kalau kita ambil semua kali dengan 45 kali dengan 1.6. Kamu ambil cos tu semua sekali. Boleh, tak ada masalah. So the answer is 70.9 ataupun kalau kita ambil dua tempat perpuluhan of cos, you are going to end up dengan 70.56. Either way, you can have it as 71 meter. Ini antara equation, antara soalan-soalan yang kita selalu jawab based on projectile and equation of constant acceleration. Okay, I know that this topic is quite a headache. Okay, it is a lot. So please go slow, review back this video later on, and try to get the idea behind equation of constant acceleration, because that equation, those three equations is quite important in order to solve most of biomechanic analysis, because our motion in fluid condition is actually a projectile. Most of it is projectile. Okay, so that's all for today. We are going to end now.